Next, we have this NAT called NAT-T, which is NAT Traversal. It's not exactly a type of NAT, okay? But because it has the word NAT in it, it has been put in this category. It is not really a NAT, as you will see in just a moment. So what exactly is NAT-T? Let's go to the drawing board. So now we are talking about NAT-T, which is NAT Traversal, okay? So NAT Traversal is used when you are building a VPN tunnel. We are going to be discussing VPN tunnels in detail later within this domain. Okay. So let's say you have got two routers between which you have built a VPN tunnel. Okay. And VPN tunnel can be built using multiple protocols. So NAT-T is used when you build a VPN tunnel using the protocol called IPsec. So IPsec is a protocol that can be used to build VPN tunnels. Now, IPsec uses a protocol within itself because IPsec uses multiple protocols within itself, okay, for multiple purposes. So one of the protocols that it uses to transfer the traffic from one destination from one source to another destination is ESP. Now, ESP works at layer number 3 of the OSI model. And ESP is a portless protocol, which means it does not have the concept of port number. So ESP is a portless protocol. Now, what can happen because of this? Let's say that there is a network here, okay, and then there is a network here. So this is network A, and this is network B. Network A wants to communicate with network B you over this VPN tunnel, this IPsec VPN tunnel, and this IPsec VPN tunnel is using ESP to transport the traffic. Okay. Now, as I said, ESP is a portless protocol. Now, let's say because this is a VPN tunnel, that means it would be going over the internet. Then that means there could be multiple devices between these two routers, and one of those devices could be a firewall. For example, there is a firewall somewhere on the way in between. This is a firewall. Now on this firewall, maybe somebody has configured PAT, port address translation, right? Now, when this router, let's call it R1 and this is R2. When R1 is building a VPN tunnel with R2, it will then send some packets using ESP protocol. That means it will encapsulate those packets in ESP. And as I said, ESP is a portless protocol. So when those ESP packets reach this firewall here, this firewall is configured to perform PAT, which means it will NAT the IP address, but for patting to happen successfully, it will also have to translate the source port number. So the source port address, the source port number into some different port number, right? But ESP is a portless protocol. That means in those packets, this firewall will not find any port numbers. So PAT will fail because for PAT to function, it needs both the IP address and the port number. But ESP is a portless protocol. That means it would have sent those packets without the port numbers. So firewall will say, hey, I want to translate this. I want to perform PAT for which I need the IP address and the port number. But you have only IP address in your packet, not the port number. So I will drop the packet. So this firewall will then start dropping those ESP packets because ESP packets are portless packets and firewall has been configured for PAT and PAT needs port numbers. So to overcome this problem, we have this feature of NAT-T, NAT Traversal. So you will configure NAT-T on these two routers, NAT-T here, and you will enable NAT-T here as well. So there are certain commands that you need to run to enable NAT-T feature. And once the NAT-T feature has been enabled, then what these two routers will do is they will say that, hey, okay, we have been configured for NAT-T. So before we can actually start exchanging packets using ESP protocol, let's first of all check if there is any device in between which could which could cause problems for the ESP packet. So they will exchange some packets to detect if there is any firewall or some other device in between which is performing PAT. And if they detect such a device over the on the network which is performing PAT, then what they will do is they will encapsulate the ESP packets into UDP packets. So this is how the ESP packets would look regularly. Okay. So for example, it will generate some ESP packets. So we have some data. Okay. And then it will have some ESP headers and trailers. Okay. And these headers and trailers will not have port numbers. And because it will not have port numbers, these packets will get dropped at this firewall. So R1 and R2 have been configured with the NAT-T feature. With the NAT-T feature, they will detect if there is any such device in between, which could be a problem for these ESP packets. If they detect such a device that is performing a PAT, then they will start encapsulating their ESP packets in UDP packets. Okay, and UDP is a protocol that uses port numbers, and in this case they will add a port number of 4500 and some destination port number as well. And now these packets have got port numbers in them. So now these UDP packets will go over the tunnel, and this firewall will say that, okay, I'm performing PAT, so give me your IP address. It will find the IP address in the packet, and it will also find the port number, which is 4500 here, and it will translate the port number as well. So now PAT will happen successfully, and now the packet can traverse this firewall and reach to this router R2. Router R2 will remove these headers and trailers. It will find the ESP packets, and then it can forward those ESP packets over to network B. So once again, what is NAT-T, NAT Traversal? It is a feature that is enabled when we are configuring VPN tunnels, and it is enabled on these two VPN headends. You enable NAT-T feature. When NAT-T feature has been enabled, then these two devices check whether there is any device on the way that is performing PAT. If they detect such a device, then they start encapsulating their ESP packets into UDP packets, and they start putting port numbers. Port number is UDP 4500, and because it has a port number, PAT can be performed successfully. But if they don't detect such a PAT device in between, then they don't have to encapsulate ESP packets in UDP. That is NAT-T. So it's not exactly, as you saw, it's not exactly a type of NAT, but it has been put into this category. NAT Traversal. So let's go to the mind map here. NAT Traversal, not exactly a type of NAT, but a feature that helps move IPsec VPN packets through a NAT device. NAT PAT between two VPN endpoints breaks IPsec AH or ESP connectivity. AH is another protocol that is used by IPsec. With NAT-T enabled, the ESP packets are encapsulated in UDP, which can then traverse a device performing address translation. That is NAT-T. All right.